Here we are again. It's Ben and Pam's Calculus Hour, it feels like. Today we're going to, okay, Ben, say hi.
Hi.
Today we're going to look at number 2. Let me go ahead and get my calculator. You sound so excited to be here.
Yeah, I am.
Okay, we're going to look at this. We can use a calculator on it. Quite honestly, I've been using a calculator on all of them right now because I want to. If this were getting tested, some of them you could use a calculator on, but most of the time, if this were getting tested, you would not be using a calculator on this. So, but this one says we can. So let me move it over here to the side. And it says find the volume of the region enclosed by. So let me go ahead to my y equals and put in x squared plus x. Now, it says y equals 0. So y equals 0 is just your x-axis. You good with that?
Yes.
And x equals 2 is just a vertical line at x equals 2. But I can't put that on here, so I'm just going to put this on here. And I'm going to go ahead and hit, let's make it in a little bit closer. Let's do our window like they have it. So I'm going to go -1 to 4 and -1 to 6 graph. Okay, I'm going to take a picture of it. Oh, I can't take a picture over here. Hold on. Let me pop over here to a notebook and do it there. So that way I can draw on it. Okay, so we're going to look at this one. So let me take a picture of it too. I gotta do this. Send a current page. Let's go ahead and grab. Is there 2 more to it? 1 more to it? Okay.
It's just A, B, and C.
Okay, cool. And we gotta do this, and we'll send that to a new page. And then we'll jump over here so I can write on it. Thank you for being patient with me. And we'll
Thank you for doing it.
Oh, no problem. Oh, where'd it go? And I'm gonna take a picture of. Come on, you turd muffin. Take a picture of this. And we are going to send it to the current page. Okay, so let me zoom that out, get rid of that, get rid of that. Take this to our first page. Okay, now we're in business. So this is what we're looking at. So I'm just going to take it and put it right there. Okay, so now I'm going to draw on it. So we are going to have y equals 0. Oh, that helps if I turn my stuff on. Cancel, cancel, cancel. What are you doing? Okay. Y equals 0. X equals 2. So we're looking at this area in here. You good with that?
Yeah.
Okay. So the first thing we're going to do is we are going to go about the x-axis. So you have to ask yourself when you're looking at it, are you flat against the x-axis? And we are. So we're going to use the disk method. We are going to go from 0 to 2. You're going to put a pi out front. And then you just have an r. Our r is just, we're going from here to here. Gosh, pretend like that's straight. That is awful. Our r is just x squared plus x. Okay, and that's what we're going to be rotating around. So I'm going to come in here and I'm going to say x squared plus x, quantity squared, don't forget to do that, dx. And then I go right to my calculator. And I can go, let me get out of here, alpha window number 4. Now, I don't notice I don't put the pi in there. I can. I'm just going to,
pi in at the end.
I'm going to go from 0 to 2. Make sure I open up another parentheses, x squared plus x. Close that parentheses. Square the whole thing. Dx. Now, because this is a calculator problem, I'm going to go ahead right here and just say times pi. And I'm going to get 53.617. Okay, so if like it were on a test, on like the big test, I would put 53 point.
Put it in terms of pi.
But I mean, I can do it. I think on the homework, I think it was like 17.067 pi.
It is.
Okay, that's kind of a jacked up way to do it, but with it being a calculator problem, because you're getting something that's not accurate, the 17.607, and you're putting it with something that is accurate, a pi. So really, the best answer I would do on this one would be 53. 0.617 or the 17.067 pi. You okay with that one?
Okay. Yes.
Okay. So now, okay, I'm going to do this again. But this time, I'm going to use the line this time. I'm going to pick another color though. Let's do green for green waves. And I'm going to go about the line y equals 6. 1, 2, 3, 4. So it's at the very top. So we are going to be rotating about that line.
So is it flat against it?
Is it? You tell me.
I think so.
But is it? Because this is how I screwed up this one. Aren't we doing this area in here?
Oh, we are?
We are in this area that we said we were doing over here.
Yeah.
So if that's the area we're doing over here, it's not flat against it. When the first time I did this problem, I did it wrong because I did the inside. You're supposed to do this like weird triangular shape over here. So if I'm going to do that, my phone has been going crazy. I'm not flat against it. So this one is gone. Okay. I'm going to have to say, okay, and let me highlight it. It might make it easier to see it. If I go ahead and come in here, is it not going to let me highlight? Oh, don't let it be frozen. Oh my gosh. Okay, now so we take a deep breath. I'll step out of the room and I'll come back in. Crapola. Oh. I see things happening. Okay, let's get rid of this. We'll just leave that little green thing down there because I don't want to mess with it. We're going to come here. Okay, anyway, it's this yellow area in here. I don't want to hit anything else again. So if it's this yellow area in here, my R is going to be going from this blue dotted line right here and up. Okay? My little r, now you have to be careful right here. My little r is going to be going from here and up because this is the part I want to take off. So this is my capital R. So my capital R is just what we're at 6 is R is 6.
6. Yeah.
My little r
6 minus
perfect.
X squared plus X.
Yep. So I'm going to say pi integral. Now this time we're still going on the X, so it's a 0 to 2. And we're going to say capital R squared minus little r squared dx. And I'm going to let you pop that in your calculator. You can do that.
Okay.
Good with that one?
Yeah, I'm good with that one.
Okay. Let's go ahead. Let me clone this guy again.
And then so for C, would it be just the exact same thing but with 9?
Let me make sure it comes up over here. Is it so? Yeah. So I would just, instead of 6s, I would have 9s.
Okay.
Good with that one?
Put the next graph up there. Yes, I am.
Okay. Do we need to look at anything else?
No. What I was having trouble with is just like setting it up. Can we look at 3A real quick? Just 3A.
Let me talk real quick about this one though. Let's say this one, just to make sure we get it. Okay. Let's say this one, instead of going about this, let's say we go about the line. Let's say x equals 3, because I want to do one where we're doing it along the y-axis too. Okay. So we already know that our area that we're looking at is this area in here. Okay, that's the stuff that we're rotating. And this time we're going to rotate it about this line right here, x equals 3. So my capital R would be that. Okay, so my capital R, so we know we have to use the washer method. So my capital R would be, 3? Let's see how I'm going to do this. 3 minus R x squared plus x. Oh, no, but we can't do, no, I can't do this one this way. Because what I would have to do, let me do it this way. Let's say that this function right here, we know that it's f of x equals x squared plus 3, right? We know that.
Yeah.
Oh, I'm sorry, x squared plus x, not 3. Don't say yeah if you don't believe me. Okay,
I
so
was kind of confused because it had
well,
an
don't
x
say
equals right
yeah.
there, so it was like a little. Okay.
So what I would have to do for this one, I went all in terms of dy because I'm going about a y-axis here. So I would have to, I'm going to have to make this in terms of y. So if I got y equals x squared plus x, there's no way for me to make it an x squared equals blah, 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 y.
Yeah.
But if there was, I'm just going to call it g sub y. If there was, my r would be 3 minus g sub y. And my little r would be this 2. Or maybe we should say 3 would be just this area between here and here. And what is that radius right there going to be if this is a 2?
1.
Yeah. And that's what we'd be taking off. So we'd be having it right here. From this time, we would go from 0 to whatever they attach to up here. I can't remember what it is. So if, say, this is 0, we would be going up to D.
6.
Is it 6? Okay.
Yeah.
6. We have our pi out front. We have our capital R minus our little r, and we'd be in terms of y. I just kind of wanted you to see a sideways one. You okay with that?
Yeah, I am.
You sure? Don't say that because you're just trying to make me happy.
Yeah.
Okay.
No, I am actually.
Okay. So what was the other one you want to look at?
3A.
3A. Okay, so on 3A, y equals 8x equals 6. So let me just take a quick picture of it.
So with it being the x-axis, does y equal 0? Or?
Hold on for a minute, because I can't. I got to be able to draw on it. I'm a real visual person.
Yeah.
I can't visualize stuff. Okay, so if I'm looking at this, I know y equals x cubed is one of those.
Yep.
And this is 2, 8. And this is 1, 1. I was trying to get it to be a little accurate. And x equals 0. X equals 0 is that line. Y equals 8. 1, 2, 3, 4, 5, 6, 7, 8. So the area we're looking at is the area in here. Good with me?
Why do you how do you have like the 1, 1 and 2, 8?
All I did, okay, hold on yourself. I put 1 into there and I got a 1 back out. I put 2 into there and I got an 8 back out. Crazy.
Right, yeah.
Okay, but I'm going to move them out of the way. Okay, so now I want to take this thing and I want to rotate about the x-axis. So my capital R is, it's 8 away, right?
8. Yeah.
My little r is just my x cubed. So I'm going to have pi 0 to 2. 6.
Why is your little r x cubed?
Because you're wanting to take the hollow part out of it. This part that's not colored in, that's the part we're taking out. What you see right here, basically, when I'm going from 0 to 2, this long line in green is basically taking this whole rectangle. And it's found the area of that whole rectangle.
You're cutting out the exterior
Yeah.
area
Yes,
of
exactly
the x-cubed
right.
line.
Yes.
Okay.
Yeah.
That's where I was having kind of trouble, was picking out which one was like big R, little r.
Well, I screwed this one up actually, and I was talking to Shane about it, and we kind of walked through it together and figured out that you always, the little r is always taking the hollow part away from it. Okay.
Yeah.
Or the empty part, the part that's not colored. I don't know how you want to think
Little
about it.
r is like the hollow part.
Exactly right. Yes. Yep. So are you good? Anything else?
And so I just I don't integrate that.
Yeah. I mean,
Like
once you find the volume.
Can we finish that part of this one out?
Yeah. So if I integrate this, I've got my pi out front. The 64 is just going to be 64x. This is x to the 6th. So my integration is 1/7 x to the 7th. And I'm going from 0 to 2. So I've got pi. And then 64 times 2 is 128. Minus 2 to the 7th is 128 over 7. And then if I want to get a common denominator, I'm going to have 896 minus 128. I end up with 768 pi over 7.
Okay. Thank you so much. That helped a lot.
You're welcome. You enjoy your break.
Have a great spring break.
You too. Talk to you later. Bye.
All right, bye.